Okay, well, let's just get going. Again, welcome to our second class at Disney-McLane University. I'm your host, Jim Huseman, and today we will be going over thermostatic mixing valves, hosted by Bruce Fathers from Powers Controls, a division of Watts Water Technologies. During the course of the presentation, if you have any questions, please use the chat feature at the bottom right corner of this program. And at the end of the presentation, I'll ask your questions to Bruce, and he'll get some answers for you. Also, at the end of this presentation, I'll send out ASSE CEU credits. Please let me know if you do not receive one. I'll get it right over to you. So without any further delay, I'm going to hand it over to Mr. Fathers.
Okay, thanks, Jim. Just to give you a little brief background about me, I've been with Powers for 23 years and a part of Watts for the past 14. And that experience primarily revolves around mixing valves. And I was with Chicago Faucets for 7 years. So I've been around the plumbing industry for quite a while. So the purpose of this presentation is to primarily give you an overview of the mixing valves standards, the ASSE standards that dictate performance of both point of source and point of use valves, as well as talk a little bit about the codes, particularly in your area, that reference these standards. So this first slide is essentially kind of, again, a general overview of a hot water tempered system. It's somewhat simplistic, but conveys the different types of point of use devices, mixing devices, from the point of source down by the boiler through the different, we call point of use devices at the showers, at the labs, at emergency fixtures. And you can see some of the various standards that we'll get into more detail on. So again, mixing valves, the performance is dictated and certified to the ASSE standards, the American Society of Sanitary Engineering, and there's their website up there. So if you ever have any issues or questions on is a particular valve or product listed or certified, you can go to that website, and that'll tell you under the listing section. So the primary standards that we're going to focus on are what you see there, 1016, which is essentially the bath shower standard, 1017, which is the point of source or hot water distribution standard. We're not going to talk too much about 1062, but we'll make it available. We'll just briefly make you aware of it. That's the high temperature shutoff standard for showers and lavatories. Then 1070, which is a hot growing category, that's hot water temperature limiting, which primarily focuses on lavatories, the standard for lavatories, also whirlpools and baths. 1071 is the emergency fixture tempering standard. 1069 is for single temperature bathing, which is essentially your push button metering, could be infrared showers. And then there's also a standard 1066, which dictates performance for inline pressure balancing devices. So just to, again, looking at the ICC website, and the plumbing code map, which this is for IPC for the states here in this the tri-state area. So just checking that out before I came out. It looks like IPC, the 2006 version is pretty much adopted in Indiana, 2009 in Ohio, and then in Kentucky there's some state-specific codes. But these all reference for various applications, ASSE 10 certified 1016, 1017, 1070 devices, and we'll get more into the specific language revolving around that. But that's a good website to go to. It even breaks down adoption. I think you can even get it by county. So there's, if you go to the ICC website, they have really good information on maps for their plumbing codes. So I want to start out with talking a little bit about the ASSE 1017 standard, which was last revised in 2009. And again, this is the standard for hot water distribution for product that is essentially located down in the mechanical room around the boiler, hot water heaters, that's distributing water throughout a facility and to the various fixtures and other mixing point of use devices. So some highlights of the standard. Again, this is controlling inline water temperature at the hot water source, which we just talked about. The standard focuses on protecting against temperature changes. There's really nothing in the standard that addresses pressure. This is obviously not intended for end-use applications. So most manufacturers, including Powers and Watts, make it very clear that when you're using something like this, we highly recommend you have a 1016, 1069, or 1070 mixing valve at the point of use. So temperature control of these devices varies based on capacity. You can see down below the chart there. So depending on the overall capacity of the device, it's going to tell you what the permissible temperature variation is. So obviously, the higher capacity, it provides a little bit more leeway. And this is above and below the set point. So for smaller devices, you're looking at plus or minus 3. For mid-size devices, plus or minus 5, and anything over 40 GPM allows you up to plus or minus 7 control. And again, this gets back to why it's important to have a point-of-use device as well. It tests valves at a pressure differential of 10 psi, and then it reduces the flow rate by 50%. So that's important to know in terms of minimum flow control. So that's how the valves are tested, right? They normalize at a 10 psi drop. They reduce the flow, whatever the flow is, they reduce it by 50%, and then they run the test. So you have to be, when you're looking at spec sheets, and you have to pay close attention to manufacturer's stated minimum flow, and understand that a lot of manufacturers may state that flow is below this particular test, and you just want to make sure that when you have a stated minimum flow that it complies with the ASSE 1017 standard. And again, this is the hot water temperature. Again, this is a temperature, there's a temperature test, not a pressure test, and they essentially are increasing hot water temperature 25 degrees every 5 minutes. So that's essentially how the temperature is applied. Then for 1016, this is for individual shower valves and tub shower combinations. So now we're getting into the point of use side. Some highlights of the standard. This is intended for wall-mounted showers and tub showers. The bather or the bather's attendant, if you're in let's say in a nursing home facility, has access to the flow and final temperature control. And there's no further mixing downstream from an ASSE 1016 device. So ASSE 1016 essentially has 3 different types of valves or technologies that's allowable. One of the most common is type P, which is pressure balancing. Then there's type T, which is thermostatic. And there's type TP, which is combination thermostatic and pressure balancing. Essentially, it's the requirements of the type P and the type T. And we'll talk a little bit more about each of these. So with a type P valve, essentially it's focused primarily on pressure changes. The type P valve does not have anything in the standard which varies incoming temperature, just pressure. So it's increasing and decreasing hot and cold water supply pressures by 50%, and then based on that, from where your set point is, you've got to hold plus or minus 3.6 degrees Fahrenheit, and they do a very good job at that. They're tested to a minimum flow of 2.5 GPM or the manufacturer's stated minimum flow, whichever is less. And then for the cold water failure, if you lose cold water, it's got to reduce flow to a half a gallon or less, or 30% of the manufacturer's stated minimum flow prior to the temperature exceeding 120. So it's got to do it fairly quickly. So that's the first type of a valve, is a type P pressure balancing valve. Then there's a type T valve, which is essentially a thermostatic valve. Now, thermostatic valves are required to compensate and adjust for both pressure and temperature. But you can see on the pressure side, it's not required to do quite the job that the pressure balancing valve is. So it must account for 20% versus 50% of increases and decreases on the hot and cold water supply pressure. But it does, however, must accommodate for temperature changes based on hot water supply fluctuations. So that could be, that could be from a result of a number of things. It could be seasonal temperature changes of water, cold water. It could be increases in hot water incoming supply due to malfunction, somebody turning up a boiler or water heater, however that happens, thermostatic valves have to have some type of means to compensate for that. They must control to plus or minus 3.6 degrees Fahrenheit, like pressure balancing. However, they're given 5 seconds to do that. So with a thermostatic valve, it typically responds to pressure changes based on the impact pressure has on temperature. So within the first 5 seconds, I believe it allows plus 5, minus 9, but after 5 seconds, it must be plus or minus 3.6. So you're given a little bit more time to make that adjustment. The minimum flow and the cold water failure tests are identical to the type P valves that we talked about a little bit earlier. So then the final type of 1016 device is a type TP, or temperature pressure. So this is kind of, I guess, could be considered to be the best of both worlds. It's got to, basically, like a pressure balancing valve, has to accommodate for 50% pressure fluctuations and changes. And like a T valve, it also has to compensate for temperature changes as well. And now this must hold plus or minus 3.6 within a second, or virtually almost immediately, similar to a type P valve. So this would probably be considered to be probably the highest standard or level of protection that's available. These valves typically are a little bit more money, but they essentially make the adjustment for temperature and pressure, and the pressure piece to the higher level. And again, the minimum flow requirements are the same, as well as the cold water failure requirements. So this is for essentially individual shower and tub shower combination products. And looking at IPC 2009, if you just want to reference, see how these are referenced in 424.3 individual shower valves. So again, I'm not going to read that, but it covers basically that you must comply with either the pressure balance, the thermostatic, or the combination type valve, and also must be equipped with a means to limit maximum setting of the valve to 120. That's essentially the high temperature limit stop. So that's essentially limiting the travel of the handle to the hot water side of the valve, and you must be able to limit that via mechanical means to 120 degrees Fahrenheit. So that's the reference point in the standard. Now IPC is on a 3-year cycle, so there's a 2012, there's a 2015, there's a 2006, but right now, based on what I saw on the website, this seems to be the current code adoption and revision for this particular area. So going from one point of use valve from the shower to the laboratory, the 2004, which I believe is the most recent version, this is for the standard which dictates water temperature limiting devices. So you're essentially limiting the temperature, if you can see from that diagram, you're limiting the temperature to the hot water side of a valve. This is primarily used for sinks, lavatories, and whirlpools. And it may, according to the standard, this may or may not be the final tempering device. So in this instance here, you can see it's feeding the hot water side of a two-handle faucet. You can obviously make adjustments to temperature above the deck there too when you're with the cold water, throttling that up and down as well. So with a 1070 device, final temperature, can be user adjustable. It's to minimize scalding risk, not thermal shock. That's a difference between 1016. 1016 is kind of intended to minimize the risk of thermal shock, which is sudden changes in water temperature that may cause the bather to move suddenly and fall or slip. That's essentially part of the shower valve standard. It's a little bit more critical when you're in a shower versus, let's say, a hand washing situation. So it's intended for single or multiple fixtures, and obviously you've got to be able to prevent crossflow, so there's checks or check stops that are a part of the valve level. So the ASSE 1070 requirements, essentially it's somewhat similar to a shower valve type T standard. So you're required to make the 20% compensation for 20% changes and fluctuations in hot and cold water supplies, plus as well the hot water increased temperature. One of the key differences is, though, because it's a hand washing application, they're a little bit more relaxed on the tolerance, the temperature tolerance, the set point. So it actually allows you plus or minus 7. I think many valves actually outperform that. And these are the minimum requirements, obviously, that we're talking about. Minimum flow is the manufacturer's stated minimum flow, so that's where they're going to test the valve. And then you can see the cold water failure is 0.2 GPM or 20% of the minimum stated, whichever is greater. So that gives you an idea of the amount of flow that's allowed in the event you lose cold water failure. Checks are required, and again, you have to have a mechanical means to limit the hot water temperature no more than 120 degrees. And here's the section in IPC 2009 416.5. This is under tempered water for public hand washing facilities. Tempered water shall be delivered from public hand washing facilities to a device that conforms to ASSE 1070. Pretty straightforward there. And then here's the language 424.5 for bathtubs and whirlpools. And there's, based on the revision, the language, whether it's 12, 2006, 2003, whatever, the language doesn't really change too much. There's been some adjustments to the language, but it's pretty consistent based on the revision. And then even for bidets, 1070 would be the performance standard that would be required for bidets. And here the maximum temperature is 110. Okay, so 1069. This is entitled Automatic Temperature Control Mixing Valves. This is more for single temperature water. Typically, I think of this standard as kind of the multi-shower, gang shower standard with, single push button. It's providing single tempered water at a preset temperature through a single pipe. So again, metering could be infrared showers, push button on off, single temperature showers. That's the key for 1069. So it could be single, multiple fixtures. Important distinction here is the bather cannot adjust the final temperature. That's really up to the installer or the facility owner. They make, this valve is typically going to be, behind a wall, up in a ceiling, somewhere where the bather does not have adjustment. All they're doing is turning water on and off. And it is considered, there's your 120-degree max with a mechanical limit stop, and it is considered a final tempering device. And essentially, again, this particular standard is very similar to a Type T standard. Actually, it's almost identical. Must accommodate 20% pressure changes and increases in hot water temperature. Now, because it is a type T, it allows you 5 seconds to make the adjustment to the plus or minus 3.6 or 2C. And there's your minimum flow at 2.5, or the manufacturer's stated minimum. And the cold water failure allows you a little bit more water for larger valves, 1 inch and up, versus 3/4, which is a half gallon and below. And then here's section 424.4, which references for multi-gang showers, which references 1069. So I've kind of presented, the various standards here and some of the kind of the highlights of what they're comprised of, and I'll just do a quick overview, just specifically comparing one to another, just as kind of a review. So how does 1016 differ from 1069? Okay, well, 1016, again, is for individual showers with hot and cold water supply, and 1069, again, is for preset water temperature or single pipe supply. And ASSE 1016 allows you 3 different types of valves, TP, T, and P, and essentially 1069 is just focused on one type, which is very similar to a type T valve. A little bit more on the 1016 valves can be adjusted by the bather for temperature and volume, and with the 1069 valve, again, it's adjusted by the installer or the facility owner. For 1016, the valves are tested to a minimum 2.5 or the manufacturer's stated minimum flow, and actually that's similar. That's the same as the 1069. So in that way, they're actually alike. And that recently, I think, changed on 1016 at the last revision to test. It used to be, I think, just a straight minimum of 2.5, and now they're testing to the manufacturer's stated minimum flow if it's indeed less. So what about 1016 versus 1070? Well, 1016, again, is for individual valves and is the final tempering device. The 1070 is more for laboratories and tubs, and it's limiting the hot water supply, and it may or may not be the final tempering device. So that's where the 1016 valve is the final tempering device. A 1070 valve may or may not be the final tempering device. 1016, again, includes the 3 types of valves that we talked about earlier when compared it to 1069. And the 1070 is essentially almost like a straight thermostatic type T valve, except it allows for a broader variation of temperature fluctuations at that point, the plus or minus 7 versus the plus or minus 3.6. So how does ASSE 1016 differ from 1070? A little bit more. 1016 requires temperature control of 3.6, and there's the plus or minus 7 that we just talked about. And 1016, they're both essentially similar. Minimum flow is tested to 2.5 GPM or the manufacturer's stated minimum, and the 1070 is tested to manufacturer's stated minimum flow, which is typically, what you see mostly is 0.5, although you're starting to see valves below, for 1070, rated below 0.5. I think I've seen as low as, well, we just introduced some valves down to 0.25 GPM, a quarter gallon. And I know some other manufacturers have that. I've seen valves at 0.3, 3.5, and 0.4. So as these new, water conservation standards and codes and just to be more energy efficient becomes more prolific, you're seeing lower flow outlets and shower heads, thus requiring these valves to control at lower and lower minimums. So there's a trend definitely to be down on 1070 valves from 0.5 and lower. 1069 versus 1070. So 1069 provides preset water temperature to a single pipe supply again. I know some of this is redundant, but it's just kind of again, trying to help you familiarize yourself a little bit through repetition. 1070 is for laboratories and tubs, so the tempering or limiting the hot water supply. side of a valve, and again, may or may not be the final device. So the 1069 valve, again, does not allow user adjustment of flow, and 1070 valve does allow the user adjustment of flow. 1069 valve requires plus or minus 3.6 degrees, while the 1070 valve, again, is the plus or minus 7, so a little bit more forgiving with the temperature control for hand washing and tub fill. And then here's, this is just a chart, just kind of, again, I won't go into this, won't go through this, but because we've talked about all this, but it just kind of gives you a quick side-by-side comparison of the three products and the applications and what's allowable. So now that we're through those particular valves, I'll just touch briefly on ASSE 1071, which is for emergency fixtures, right? And these are to be used, installed with fixtures that comply with ANSI Z358, which I thought most of you are familiar with. So this is 1071, which is last revised in 2012. So the valves are tested at manufacturer's stated full and bypass flows at a 30-pound differential for accuracy. The valves have an operating range of 65 to 95 degrees Fahrenheit, and the outlet temperature cannot exceed 100 degrees Fahrenheit. So again, we're dealing with, flushing for obviously eyes, drench showers, combination unit. So temperature, control of temperature is critical. And then what really differentiates emergency valves is that upon hot water failure, a typical master mixing thermostatic valve, if you lose hot water, it's going to automatically shut down the cold water. With emergency fixtures, you actually want, if you're not going to have a blended temperature water, you at least want cold water. So these valves achieve that through various means, but through typically through an internal bypass in the valve. So that's one of the key differences between an emergency tempering or mixing valve and a standard master mixing valve. And then again, some of the performance requirements, vary based on, again, this is similar to 1017 in terms of, the performance requirements vary based on the capacity or the size of the valve. So along the left-hand column, you can see, as the valves get larger in capacity, there's more allowable temperature fluctuation from set point, essentially. So for the small valves, you're holding at plus or minus 3, and when you get up to the larger valves, it jumps up to plus 7, minus 15. I'm sorry, the small valve is plus 3, minus 5 there, as you can see, and then it goes up to plus 7, minus 15. So obviously they want tighter control on the plus side temperature. And then the maximum allowable flow with cold water shutoff, you can see those values as well. They increase as the size of the valve gets bigger. So I just wanted, was talking about mixing valves, I just wanted to touch briefly on this new ASHRAE standard 188P. That's basically one of the things that mixing valves do, regardless of the technology. It's obviously help minimize the risks not only of scalding, but also if you're keeping elevated temperatures within a plumbing system, which we recommend, also minimizes the risk of Legionella. There's a new standard that's been in the works for a while that I think will be published soon, but it's basically risk management for building water systems, which obviously is still under development, but it's intended for use by building owners and managers in the design, construction, and operation of facilities. And here's some specific language to that. So essentially, it's kind of helping facilities deal with the instances of let's say, of Legionella outbreak within a facility. Talk about hot water sanitization and flushing. That's one of the ways. There's numerous ways, so this is clearly one of the ways to address Legionella or bacteria outbreaks. And this is giving some guidelines to facilities on what the protocol should be to address that. And obviously, mixing valves play obviously a key role in minimizing risk to the facility. And here's one of the notes under 8.1.4 in terms of water treatment again. And you'll see some of these similar in the CDC guidelines for Legionella control. So again, recommending a hot water heater outlet temperature at least 140 degrees, and then essentially recirculating it at or above 124 is critical, again, to try and help as one of the measures, one of the steps in trying to mitigate the impact of potentially Legionella. So that's something new. You should be looking for that ASHRAE standard soon. We have a number of tools that are available, as I believe other manufacturers do as well, but these are available if you have any questions on particular, what the application is, and then the specific language. This matrix actually plays out to from IPC 2003 up to 2012 right now. We'll add 2015, but the specific language, the specific products that are applicable, and then the specific language in the code and the ASSE standard that it references. So we have a bunch of information like this available to kind of help with guidelines and any questions you might have. And along the top there is the codes that or the states that have adopted that particular revision. We do this for UPC as well. Again, getting back to some of the things we covered, if you go to our website at watts.com or powerscontrols.com or some of our some other manufacturer sites, you're going to have a lot of information on again, some of the things we covered, the differences between standards, the specifics, comparative data. I showed you a chart that compared ASSE 1016, 1070, and 1069. We actually have an expanded chart that covers all the standards, even some that we didn't really talk about in detail in some of these pieces of literature. So those are available online, or we can get those to you if you have further questions or want some more information. So that was kind of an overview, again, of standards and codes. This is your certificate of completion here that you'll receive from Disney. And that essentially concludes the presentation.
Well, thank you, Bruce. Now we'll open it up for questions. Again, if you have any questions, use the chat feature, the bottom right corner of the WebEx program. We'll start it with the first question. Is it required to install check valves at these mixing valves?
Yes, check valves should be installed at the mixing valves, and I believe most of the standards specify check valves. I know we talked about 1070. So, yeah, it's highly recommended that checks or check stops are installed to prevent, any opportunity for crossflow. So, yeah, absolutely.
Okay. How about this one? Can I use a 1017 master mixing in place of a ASSE 1071 safety mixing valve?
No, that's not recommended. And again, the primary issue there is that a standard ASSE 1017 valve, if you lose hot water, it will shut off the cold. You'll have no water at all, or essentially you might have a trickle. A 1071 device, if you lose your hot water, it's got an internal or external cold water bypass that will at least provide cold water to a drench shower and eye wash. So yeah, that's one thing you do not want to. You do not want to specify 1017 on an eye wash or a drench shower.
Okay, okay. One last question. If I have a 1017 master mixing device, do I need a 1070 device at the labs?
Well, if you look at most codes, I mean, they do specify both. I mean, you obviously, we highly recommend it, yes. I mean, whether it's a 1070 device at the lab, a 1016 device at the shower, a 1071 device, a 1069 device, you want redundant protection. You want to make sure that, I mean, there's reasons that hot water temperature can change or become elevated, so you clearly want the protection, the first layer protection at the point of source, or, you know, right around the mechanical room of the boiler, but you also want that last defense at the point of use. So highly recommend that you have both.
Okay. Okay. Any more questions out there? All right. Well, thanks again, Bruce. Again, at the conclusion of this presentation, I'll send you your ASSE CEU certificate, like the one that's presented on screen right now. Oh, we do have one more question. If the hot water is 124 degrees Fahrenheit, can a 1070 handle this?
Yes, it can. I
Okay.
mean, one thing you have with pure thermostatic valves is we call it approach temperature is very important. So the approach temperature is the difference between incoming hot water supply and the maximum hot water temperature you can get out of the valve. So we can handle 124, and this can vary quite a bit based on manufacturer. So obviously, the lower the approach temperature, the better. So some valves would have an approach temperature of 5 degrees. Okay, so that means if you got 124 coming in, you can get 119 degrees going out. All right. Some valves, depending on, you know, the manufacturer, the type of valve, I've seen approach temperatures at 20 degrees. So that means the maximum temperature you're going to get out of a valve with an approach temperature of 20 is 104. So that's an important thing to note when you're specifying product. I mean, we have you know, issues if your incoming hot water temperature was lower, and you've got a high approach temperature, you know, people may not be getting hot enough water. That's typical in shower installations. But kind of a long-winded answer, but yeah, to the question, yes, it can handle 124 degrees.
Great, great. Okay. Again, I also see there's a question if I can email this presentation. Yes, of course. If you'd like a copy of the presentation or a recording of this presentation, please give me an email. I'll send it to you. And yeah, be sure to join us next time. Our next class, Disney-McLane University, is July 10th, covering safety eye wash and shower devices, hosted by Mons from Speakman. That concludes it. Thank you, everybody. Have a good day.